So now that we finished up talking about rational numbers, we can now look at how all of the exponent rules apply to rational numbers. So let's just do a quick review of the exponent rules. Maybe some of these will look new. But the official definition of a to the nth power is that you have a multiplied by itself n times. So that n up there tells you how many times to write down the base. And a is called the base, n is called the exponent. And with the properties of exponents, we learned that if you have like bases, see how our a's are alike? If you have like bases and you're multiplying, you add the exponents. If you're dividing like bases, you subtract the exponents. So those are like direct opposites of each other. If you have a power raised to another power, so an exponent raised to an additional exponent, you would multiply the exponents. If you have a product, so some numbers multiplied together, that the entire group is raised to a power, that means that that exponent gets applied to everybody in the group. So it gets applied to the a and also the b, still multiplication. If you have division raised to a power, then the numerator and the denominator will both get that power. By definition, any base raised to the 0 power is 1, as long as the base isn't 0. So by definition, this is something that didn't make sense, so the mathematicians had to define it. So a to the 0 power is always a 1. And then negative exponents. So the negative exponent, this is always the way, this is the analogy I always use when I teach this. The negative exponent means that he's negative, right? He's upset, he's sad. He's negative. A is negative. He's mad. That's not where he wants to be. He wants to be down in the basement. Like, Dad, just let me go down to the basement, right? I'm happier in the basement. So fine. If he's negative, let him go down to the basement. And now do you see that the exponent is positive? Because now he got to go where he wanted to go, and now he's happy. And so you can take the negative off of the exponent when you move it to the other part of the fraction. So the negative means that this base and the power really want to live in the other part of the fraction. So that's why we moved them to the basement. So if you start with a fraction and you have a negative power, this means everybody's unhappy. Everybody inside parentheses is unhappy. A doesn't want to be where he is. B doesn't want to be where he is. They want to switch. A wants to go to the basement. B wants to go upstairs. So they're negative. If you would switch them, then they are happy. Now they're positive. And I know that's such a dumb way to think about this, but that's what works for my brain, so I figured I would share it with you guys. Maybe it'll help you out. So let's do a few examples. We're going to write each of the following in the simplest form, and we only want to have positive exponents in the final answer, so no negative exponents. All right, so we have a to the 5th divided by a to the 7th. You are dividing like bases, so the rule says we subtract the powers. So we can combine them into a to the 5 minus 7 power. And 5 minus 7 is negative 2. So the only problem is it said we don't want to leave anybody negative, no negative exponents. So that means he'd be happier in the basement. And then you can just make it an a squared. So 1 over a squared. That's how that one would simplify. We subtracted the powers and then moved this negative exponent to the basement to make it positive. Part B, b to the 5th times b to the 10th, where we're multiplying like bases, so the rule says we can add the exponents. So that would be 5 plus 10, so that's going to be b to the 15th. No negative exponents, it's all good, so we're done with that one. That one's a pretty quick one. You can pretty much do those in your head. All right, let's look at the next couple. 2xy, all in parentheses, cubed. So that means everybody inside there is getting cubed. So this is going to be like this power where we have the, or this rule where we have the parentheses with a power. So that means the 2 gets cubed, the x gets cubed, and the y gets cubed. Everybody gets cubed. And 2 cubed is 2 times 2 times 2. There's 3 2s, so that's 8. So 8x cubed, y cubed. No negative exponents, so we're good to go with that one. Everybody gets cubed. The next one is a division problem. We have 8 to the 15th over 8 to the negative 4 power. When you have like bases and you're dividing, this is going to be like part A where we subtract the powers. So it's going to be 8, that's our base, 15 minus negative 4. Now you have to be really careful because you're subtracting a negative. 15 minus negative 4 actually turns into 19. So 8 to the 19th. And you might say, well, wait a minute, that's a number. Why don't you put it in your calculator? Okay, it's huge. I don't want to put it in my calculator. It's some gigantic, crazy number. Let's just live with 8 to the 19th power as a good enough answer on that one. And then the last one, we have a fraction raised to the negative 4 power. I know it's kind of hard to see that little negative, but that's a negative 4 power. So the rule says if you have a fraction to a negative power, you flip the fraction, and then you can take the negative off. So we're going to flip the fraction. Now everybody's happy, and it's just a 4th power. And if you have a fraction all raised to a power, that means the numerator gets the power, and so does the denominator. Now these numbers aren't going to be quite as big. 7 times itself 4 times is 2,401, and 2 times itself 4 times is 16. And I believe that cannot be reduced. I believe 2401 is a prime number. And then 16, of course, is a bunch of 2's multiplied. So that would just be the answer on that one.